So let's get started with the demo. As you can see here, I have multiple windows or tabs up in my browser. So the first one is a link to my Red Hat Openshift console where I have admin access. You will notice we have this icon at the top. This is what you get when you install the Cloud Native Toolkit. And it provides a link to all the tools that are available. So here is a link to the Red Hat Container Images catalog, which we will reference later. A link to my IBM Cloud account, and the credentials to my Watson Assistant service, which our app will need eventually. And here is my new repo, which you can see is a fork of the original repo from IBM. So this is in my private account. So I also have a terminal window, which I'll be doing all my commands from. So if I do a get remote -v, we'll see that I am tied to my local version of the forked repo, and I'm currently on the master branch. So just a quick note on this, we will be using the master branch for all of our modifications. Obviously, in a normal development environment, you would never make changes directly to the master, but we're going to do this to speed things up. So my local system also has the Openshift and Cloud Native Toolkit developer tools and CLI installed. And if you need details on how to do this, please check out the tutorial. The first step is to log into our Openshift console using the CLI. So there are several ways to do this using the toolkit, but we will use the Openshift client command, which we can get from the Openshift console. So if we go back to our console window, there is a copy login command, which will take you to a link that you can cut and paste into your console. So I've already done that. So I'm just going to do an OC, who am I? Show that I am logged in. The next thing we need to do is create an Openshift project where we can do all of our work. And my project name is DevRH, which I've already set up. But locally, we need to sync with that. So I'm going to run an OC sync dev-rh. And the sync command will create a new project in Openshift if it doesn't already exist. And it will copy over any resources it needs to support the toolkit. And it will also set the project in our local environment. So if you notice here, this is a pointer to my cluster, and this is my project name. And here's my GitHub repo pointing in the master branch. So now that we're all set, we need to prepare our GitHub repo to work with the toolkit. And so we need to seed our repo, and we can do that with the OC enable command. And this is going to generate the needed files required to run the pipeline. So this is a Node.js, and it recognized that and picked that as a default, so I'll take that. So it says it moved, it's done and it's completed, and it's moved files into my repo. So let's go take a look. Actually, I want to run a get status because it added them locally here. And you can see it added all these files. It added this chart files, the Helm chart stuff, pipeline configuration, and a properties file for SonarQube. So let's go ahead and push these local changes to our remote repo. I'm going to do a get add a. We'll do a get commit -m. Call this OC enable. And I'm going to push this with a get push origin master. And that'll push it to my remote repo. So if we look at our forked repo here, and we can see that we have our new chart directory, everything with the OC enable tag. Jenkins file, pipeline. So all the files have been added. So before we start and run our pipeline, we will need to clean up some of the default values in these new files. So first, let's fix the Sonar properties file. Our app isn't set up for this part, so we'll take that out. And our source directory is at the root level. So I'm going to commit those changes right to master. Then we also need to check and change our Docker file. So here's the existing Docker file that already existed with the app. So we're going to have to make some big changes here. So in the tutorial, I have all the code, but I also have it here in a notepad. So I'm going to just grab that, cut and paste it in. So remember, when building a universal application image, we want to incorporate best practices and build it so it is in compliance with UAI standards. So the main requirement is that we want our image to only include the minimal amount of libraries or components and build it on top of a compliant UBI. So our new Docker file has two stages. The build portion uses a standard node image from Alpine. This gives us all the packages needed by our application, but it also contains a lot of extra stuff like build tools, which we don't need. So once the app is built, we then want to create our deployable image based on a UBI. To find the right UBI, we need to look in the Red Hat container catalog. So I can search for Node.js version 14 to find the latest UBI. And just a quick note, using a language-based UBI assures that the container will not run as root, which is always a good practice. So if you click on one of the tiles, you'll get all the tag information that you need to incorporate and insert into your Docker file. So let's go back to our, so if you notice here, this is our UBI, and the registry.access.redhat assures us that is the right one, that we're using the Red Hat registry here. Also, we are adding a license file here into the image, and we're also adding some descriptive label information, both of which are requirements for building a UAI. So let's go ahead and save that. So now that all the files are ready, let's create and run our pipeline with the OC pipeline command. First, let me make sure that I have the latest locally. I'm doing a get pull origin master. Make sure we're in sync. And now I'm going to run the OC pipeline command. It's in my stack here. There it is. So in this OC pipeline command, we've added some parameters to answer some of the prompts that it would normally ask you if you didn't supply them. So let's go back over this, what's happening. So we're running a Node.js Tecton pipeline, and we're not running an image scan. So we have scan image equals false. I know it's cut off here, but that's what it says. And image scans look for vulnerability issues. So you should definitely include in your final build, but we're not going to worry about that right now. Also, the first time you run this, it'll ask you for your GitHub account name and token. For me, it already knows it because it's saved off in my Openshift project, so we're good to go. And since we didn't include which repo branch should use, it will default to using the master branch. Part of the pipeline creation is to add a webhook to our GitHub repo. So let's take a look and see if that was added. We're going to go into settings, webhooks, and there it is. There's the Tekton webhook added. And that means that it's going to listen for any changes to this repo. So once any changes pushed, it will automatically start a new pipeline, which is real handy. So let's go take a look at our pipeline, which was started in our Openshift console. So notice I'm in administrator view and I'm filtered on, should be filtered on my project. Let's see. Yeah, I am. And you can see the pipeline has started. If we click on pipeline runs, we see the actual run started. Let me go back to pipelines. And if I click on it, it'll show you all the tasks that our pipeline is going to be running. Some of these are very obvious, but if you want to know more details, please take a look at the tutorial where we discuss what is in each one of these. So if we go back to pipeline runs, this is going to show you the history of all the runs associated with the pipeline. This is the first one in this case. So it just got started. This thing will take about 10 minutes for our app running on this cluster. So we'll wait patiently here for a second. Okay, so we can now see that the pipeline has completed. And if you click on it, you'll see that it failed in the deploy task. Since it got this far, it should have created a deployment, which we see here. And if you check the pods associated within their logs, you'll see that the reason the app crashed, it was unable to authenticate the Watson Assistant service. So we have two solutions to this problem. We can either edit the source to turn off using the service, or we can actually provide the service credentials. So turning off the service isn't great because that will affect how the application works. Basically, it won't crash, but it will have no idea how to answer any requests. So the best solution is to create an actual Watson Assistant service from IBM Cloud, which, by the way, you can do using free trial accounts, so it's not that hard to set up. Then you just grab the credentials for the service. So as you can see here, I've done that. Here is the service, and here are my credentials, which I can cut and paste from. To add the credentials to the deployment, we need to create either a config map or a secret to hold them. And for credentials, it's recommended to use a secret. So as an administrator, which I am, you can click on workloads and then secrets. And here you can see that I've already added one called Watson Assistant Slots Intro. And here are the secrets. And as you can see, the application requires the values be stored in very specific names. They're listed here, and here are the actual values from my service. So once that service is created, we need to add it to our deployment task. So we can go back out to deployments, select our deployment. I'm sorry, let me go back. And on the action menu, we could say edit deployment. And under environment, I'm going to add a secret, which I'll do here. Let me go ahead and grab that. Add it to the deployment. At this point, we'd like to restart the pipeline, and you would do that by going back to the pipelines, pipeline run, the pipeline panel, and actually just select start last run. That's how you would normally do it. But in the interest of time, let's go ahead and make one more change. If you go through the tutorial, you will see that the pipeline will fail again, and this time in the health task. And the reason is the current app doesn't have a health indicator endpoint, which is a UAI requirement. So let's go ahead and add that now. We go back to our repo, and we're going to modify the app.js file. So let me go back. I have this code stashed away. I have a little endpoint set of code here that I can cut and paste. And it's we want to enter that in the code block with the other endpoints, which you can see here. So let's go down and insert it here. So that's our new health endpoint. We'll go ahead and save and commit that right to master. And because we have that webhook, which detects that a change has been made, if we go back to our pipelines, you'll see that it's automatically restarted. So our pipeline is all green now, which means that our image has been created and deployed. So to test it, let's go to the developer view. Click on topology, and then we see our app. And if you click on the icon at the top, we can open the actual URL to our app. And remember, this is a pizza chatbot, so let's try it out. Type hello, I want a small pizza, some cheese. So it seems to understand me, so we know that the Watson Assistant service is actually running. Close that. So to wrap up the demo, let's take a look at some of the assets generated by the pipeline. If we go to the Cloud Native Toolkit drop-down menu, let me go back to Administrator. We can see a list of the tools. If we select the image registry, we'll go to the registry that is hosting our image. In this case, it's in IBM Cloud. You can find it by searching for Watson Assistant slot, which actually is showing right here. And it comes along with a version tag. Just to let you know, other registries are available and can be specified when setting up the toolkit. So you're not tied into using IBM Cloud. Now let's bring up the Artifactory Tool and see all the artifacts associated with our image. So we'll click on Artifacts, and we'll search for Watson Assistant slots. And then you can drill down to see all the image and its contents. So let's go to Sonar Cube. And see the results of how our code checks out. We click on Projects, and there's our Watson Assistant slots intro. And we can see how the scores for our code. So lastly, let's go back to our repo. And we can see that a version tag has been added. So I've run this a couple times. So the one 4 minutes ago, version 3, was added automatically by the toolkit. So to recap, the purpose of this demo and the associated tutorial is to walk you through the process of taking an app in an existing GitHub repo and building a pipeline image that can be deployed on a Red Hat Openshift cluster. The Cloud Native Toolkit helps you build an image based on UAI guidelines and best practices so that you can ensure that your image is secure, scalable, and compliant. So I hope you found this useful. If you're motivated, please check out the tutorial and try it out for yourself.